And with life. Okay, good. So lesson 1.5, solving quadratics. And when we look at that, first of all, let's break down the language. What does it mean when we say a quadratic? We already know this, right? Yep. Good, it's an equation that has x squared. If we were to make a graph of it, what would it look like? It would make a parabola. Okay, so quadratics take three major forms, right? So we usually express them as either ax squared plus bx plus c, and I'm going to say f of x equals, right? What notation is that again? Function notation. What form would we call that? Standard form. Good. Or they're expressed, how else? F of x equals, give me another one. What form do you want to do next? Vertex form. Okay, how would we express that? X minus h squared plus k. And as you know, I hate the letters. I don't care about the letters. But okay, what do we call that form? Vertex form. So called because the h and the k give us the values of the vertex, the x coordinate and the y coordinate of the vertex. Awesome. And finally, f of x equals x minus r we usually use times x minus s. Again, I couldn't care less about the letters, but what do we call this form? Factored form. Okay. So those are the three forms that we normally find an equation in. What does it mean when we say to solve an equation?
What'd you ask?
What does it mean to solve an equation?
That you are super smart.
Because we use different language. Like I say factor. When we factor something, are we solving?
Yeah.
We may be solving it in the way we use that language just in English, right? Which is we are taking something we didn't know and now we know it. Hey, I solved it, or I figured it out. But that's not what solve means in math. Not quite. And when I say evaluate, where I say f of x equals, 5, find that value, that also isn't solving, right? So if I said, don't write this, if I said f of x equals 3x plus 2, and then said evaluate f at 2, we know how we'd do that, right? What would we do? We'd say f at 2 equals what? 3, open a bracket, 2 plus 2. 3 times 2 is?
6.
Plus 2 more is?
8.
8. And so I'd say f of 2 is 8. Is that solving?
Yeah.
Again, in our day-to-day words, yes, but actually in math we'd call that evaluating. We already know the function, and the function is designed to put a number in and give us a number out. So we don't treat that as a solving, because we're not figuring something out. We're actually just using the equation to do what it's designed to do. Does that make sense? So we don't call that solving. We just call that evaluating. You could even just say, use the equation. Does that make sense? So solving in math usually means finding an unknown variable in an equation. So anytime you see solve, the answer is typically going to look something like, the setup will be, something like 3x plus 3x plus 7 equals 9. That's the setup. But the answer, once we've solved it, will be x equals something. By the way, in this case, what will x equal? 3 times something plus 7 is 9.
X has to be a negative.
Yeah, it would be 2 over 3. We could do the algebra to show why. I'm not worried about that. But the point is, in a solving setup, they give you an equation. All right, you get an equation. And when you're solving something, your answer will be variable equals a number. Does that make sense? That's what solving is. Which is still different from evaluate, right? In evaluate, they give you a function and say, put this x value in. So in that case, it's not an unknown variable. You know the variable, and you're just doing the math. Does that make sense? In this case, it is actually taking an equation where there's an unknown. This equation is not designed to solve for x. You see why we have to say that's solving? When you evaluate, the equation is set up so that the thing you're looking for is on the left, and all the math is on the right. Right? So that's not solving. You're not like puzzling anything out. You're just following BEDMAS and doing it. When it's evaluate, you can plug it right in your calculator in one step and go. Does that make sense? With solving, we usually have to do some sort of rearranging. In grade 9, you learned how to solve these, right? We didn't do the math here, but what would you have to do to solve this? You'd have to take this plus 7 and get rid of it by doing what? Subtract 7. And now you would have 3x. I guess we can show that as the middle line. The middle line would be, oh, that's not red. The middle line would be 3x equals what? 9 minus 7, which is 2, right? So what we would have done there is we would have said, okay, to get rid of that plus 7, I have to subtract 7, which I have to do to both sides. And then, how would we deal with the fact that x is being multiplied by 3? We divide by 3. So when we are doing solving, the equation isn't set up for us. We have to like manipulate it. Does that feel not too bad? That's the difference between solving and evaluating. That's the difference between factoring. We never get to the answer part, right? When we just factor something, there's no answer. When we factor at the end, we don't say, therefore x equals. We still just have an equation, right? But at the end of solving, you should have an answer. You should have the variable we were looking for equals this number I just found. That's solving. How's that feel? It's just a language lesson. All right. Linear equations are easy to solve. They just have one answer, right? So you do a little bit of addition, subtraction, multiplying, dividing, and you're done, right? You can see our example above. You ever try to solve a parabolic equation? Quadratics are hard. The reason quadratics are hard is because you don't have one x appearing once in the equation. You have it appearing twice, at least twice, right? By definition. And even worse, in standard form, one of them is squared and the other one is not. So they're not like terms, which means you can't combine them, which means none of the math tools you have will let you solve it. I promise you right now that if I gave you 3x squared plus 2x minus 1 equals 8 and said solve it, you can't do this with your normal skills. Can I show you why without you writing it down? If I do this, will you just not write it? Do you promise? Okay. So let's try. Normally when you solve this, you'd say, okay, we got to get the x by itself, right? Does that make sense? So we'd say, okay, well, to get the x by itself, what do I need to move? The negative 1, right? Okay. So I'd say, well, we have 3x squared. I'm going to rewrite it. Again, don't you write it, okay? We have 3x squared plus 2x minus 1 equals 8. I'd say, okay, I want to get rid of that, so we'll add 1 here, right? And then we'll add 1 there. So my next line, this 8 would now be a 9. And then here we'd have 3x squared plus 2x. Now what do I do? What would I do? Well, I don't know what I'd do, right? I want to get x by itself. If I try to get this x by itself, right? I'd say, okay, let's get rid of this 2x, right? Now I have 3x squared equals 9 minus 2x. Well, now it just got worse. Now I have x's on both sides. Do you see what I mean? And then I could divide by 3, I guess, right? And I'd have x squared equals 3. 9 divided by 3 is 3 minus 2/3 of an x. That looks even worse, right?
Even worse.
And now to solve for this, I'd have to take the square root, right? Well, how do I take the square root of that? Is this going to get me to x equals something? And the answer is it won't. And don't feel bad. It's not just that you can't do it, it's that it actually can't be done. You can't use BEDMAS, you can't use normal add, subtract, multiply, divide, square root, square kind of stuff to solve an equation like this. It just can't be done. The fact that the x appears in two places makes it impossible. So what do you do? So what do we do? You can't collect like terms because they're not like. What can you do? And the answer is, we've mentioned this before, we have one big advantage with parabolas, which is we can put them in a form where we can solve. And in fact, we've already solved. There's only one form of a parabola that can be solved, and it is not vertex form. Vertex form we use, but we can't actually do any solving with it, but factored form. In factored form, there is one way to solve a parabola. We can always solve a, x minus r, x minus s is that typical thing, right? When it equals one thing and one thing only. What is the one thing it has to equal if we're going to solve this equation? Because if I have to expand this out, it's going to be a nightmare, right? And if I start doing the math on this side, I'm just going to end up putting it into standard form. And we've already shown, can you solve an equation in standard form? But there's a trick. What is the only operation actually happening here in terms of BEDMAS? Well, inside the brackets, right? But we can't do that because we don't know what x is. Exponents, are there any? No. Outside of the brackets, is the division? No. Is there multiplication? Yeah, a is being multiplied by this bracket, is being multiplied by that bracket. Outside of the brackets, is there any addition or subtraction?
No.
No. Which means in factored form, the only operation being done is multiplication. And multiplying has a special property, which is there's one case that you can always solve super easily with multiplication. It's when it equals 0. All right? This is the key. The only way we are able to solve a parabola, period, ever, is when it is equal to 0. That's the only parabolic equation that can be solved. You can only solve quadratics that are equal to 0. And we always put them in what form? Factored form. Now, you should have done a bit of this last year. This is a review lesson. Do you remember solving equations like this? That's okay, because we're going to do it now. And it's actually not so hard. So we're going to do our first example, and our first example is going to be really trivial. We're going to solve the equation f of x, not f of x, we're just going to make an equation. Not function notation, an equation, sorry. We're going to say 3x plus 5 times x minus 2 equals 0. And this, I promise you, you have solved before, even if you don't know it, because the way we solve this equation is also the way we find what about this parabola. In other words, if this was our function, the function 3x plus 5 times x minus 2, we actually do this all the time. We say, when does this thing equal 0? Because the whole point of factored form is, what do these two brackets tell us? They tell us the roots, which happen to be when the whole thing equals 0. So all you have to do once you're here is you say, if we are saying that the whole equation is equal to 0, and they're being multiplied, the only way that you can get 0 by multiplying is if one of the things you're multiplying together is 0. Is it possible for the number 3 to also be the number 0?
No.
No, so we don't have to worry about the 3 out in front. But could x plus 5 equal 0? Is that possible?
Trying to break this all down.
Sure. And then what's the other possibility, of course? Can x minus 2 equal 0? So, when we go to solve this, it's as easy as saying, okay, if this whole expression equals 0, and it's all multiplication, one of the things we're multiplying has to equal 0. How many solutions is this going to have? How many answers are there going to be to this question? 2. Do we see that? There's 2 ways to get an answer. Either the answer is that this bracket equals 0, in which case x plus 5 will equal 0, or this bracket has to equal 0, in which case the answer will be x minus 2 equals 0. How's that feel? And then this math is trivial. If x plus 5 equals 0, what must x be? Some number plus 5 equals 0, the number is negative 5. I didn't even need to do any algebra, right? I can just kind of look at it. What about here? X minus some number, x minus 2 rather is 0. What's x?
2.
2. If they're more complicated, we might need to do some math. But, that's not too bad. How's that feel? Okay. And so what are the answers? Therefore, x equals negative 5 or x equals 2 are the solutions. This is an interesting thing where when we solve an equation of a parabola, there might be 2 answers. By the way, is that a useful thing in life sometimes? Are there situations in life where there's 2 answers to a question? Sure, all the time, right? So in parabolic equations, we find types of questions where there's 2 answers. And if you think about it, the one example, like some of the word problems we've done so far, one of the word problems we did was about like kicking a ball. And it starts on the ground, it flies up, and then it lands on the ground. In this case, the solution to that might be the 2 times the ball is on the ground. Well, there's 2 solutions because the ball starts on the ground, and it goes up, and that comes back down, and it ends up back on the ground. Does that make sense? And that comes up in all kinds of things, right? Anything where the direction of it changes, you might get 2 answers. So in parabolic equations, sometimes you get 2 answers. You don't always get 2 answers. Sometimes you only get 1. Sometimes there is no answer, right? We know that's possible because we know that parabolas don't have an unlimited range, right? Not every answer is possible. So if I tried to set this equal to like negative 5,000, well, maybe the parabola doesn't go to negative 5,000, in which case there's no answer to that. Does that make sense? Now, yes?
So, aren't we supposed to find the average of 2 x's?
We would want to do that if we were finding what? If we're finding vertex form. But this doesn't say put in vertex form, it says solve it. And solve it means x equals. Does that make sense? So the equation here says, take the number 3, then multiply it by any number you want, and add 5, and then multiply that by the same number you picked here and subtract 2, and tell me all the times that equals 0. Solve that. And the answer is, okay, that will work if we put the number negative 5 in, and it will work if we put the number 2 in. And those are the only 2 numbers that will make this equation true. Solve just means what value of x will make this equation true. But I'm glad you said that, because that was we've taught you a skill, right? Which is a lot of the time when we do this, what we then say is now tell me what the vertex is. So we add them together and take the average. But that would be when the question is, put this into vertex form. Then that's exactly what we do. I'm glad you made that connection. But if the question just says solve it, do I want you to put it in vertex form? No, I just want you to solve it. And that's why knowing those words is important, right? Because a bunch of you on your quiz, which I'll get back at the end of the day, when I said factor this, you put it into vertex form. That's awesome. You did great math. You actually did the harder thing. I think completing the square is harder than factoring. You did the harder thing. You just didn't know what the words meant. That's okay. Let's just make sure we learn what the words mean. So when the word is solve, it means tell me what the value of x is, and then you're done. Don't do anything else with it. Now that's the easiest possible example. It's the easiest possible example because it's already in factored form, which is what we like, and it's already equal to 0. We're going to go up 1 step in difficulty. All right? How might this be harder? In example 2, the equation is given in factored form. In standard form.
The form that we just did was factored form, correct?
That's right. Yep, exactly right. So the first example I asked you to do was just to solve this equation. In this case, we're going to say, okay, what if I give you an equation, but it's not in factored form already, it's in standard form. So what if I asked you to solve, and we'll do one here, I don't know, 3x squared. I'm going to just give me a second. I can't find where I wrote my example, but that's okay. I can do this on the fly. Do you trust me? I'll make my own up. Thank you. Plus 4. And then in the middle, I'm going to put, what am I going to put? I'm going to put 7x. Okay? And we're going to set this one equal to, I don't want to make it difficult in two places yet, so I'm going to set this one equal to 0. Okay. So it's still, are we happy with this side of the equation? Remember, we can only solve when they're equal to what? We can only solve a quadratic equal to 0. So this one is good, right? In the next example, I'm going to say, what do we do if it isn't equal to 0? But we don't have to deal with that yet because this one is equal to 0. So we can look at that and say, check. One check mark is good. But then the other thing we said is, we can only solve if it's in factored form. Is this in factored form? So what do we have to do with it? Bingo. In other words, we have to, we have to factor it, and we're going to factor it by, God, you guys are good. Yeah, does that make sense? Mm-hmm. If it has to be in factored form, then all we have to do is factor it. So I'm just going to rewrite the equation. I'm not doing any math here. I'm just rewriting it so we have a nice open space that I haven't written all over. You can do that on your page if you feel it's a little messy like mine. There we go. So the first thing we're going to do is we're just going to factor it. And this one isn't too nice because it's the AC rule, right? Don't love that, but that's okay. What's AC in this case? Right, I see that has that 3. So I can't just say what numbers multiply to 4. I'm going to have to say what numbers multiply to 12. Because 3 times 4 is 12. And what numbers multiply to 12? It could be 12 and 1. It could be 6 and 2. Or it could be 4 and 3. Any other ones? I mean, I guess the double negatives of all those, right? Negative 12, negative 1, negative 6, negative 2, negative 4, and negative 3. Anything else? I don't think so. Does one of those work?
Yes.
Yeah, which one?
4 and 3.
4 and 3. What do I do now?
You kind of decompose and you have to split the 2.
Great.
To 4 and 3.
So my next line, and here's something I want to stress. See that equal sign? Look at me. Everyone look at me. Straight line. See the equal sign? Next equal sign is going to go right below it. Nice and neat. You got that?
Okay.
Nice and neat. Do I want the next equal sign over here, and then one over there, and then one over here? No. Nice and neat. Okay? Am I neat by nature? No, I'm a slob. You got to choose to be neat. Make your bed, line up your equal signs. That's what my mother always said, except for the equal signs part. But Margep, my grade 10, 11, and 12 math teacher, boy, she told us to line up the equal signs. So, are we doing anything to the right side of this equation?
No.
So what do I just write here?
Equals 0.
Good. So listen, when we're working with an equation, you can't get sloppy. Does that make sense? Because if you get sloppy, you'll make mistakes. So right now, we're doing something new. I have to factor this side, like I always have, but I can't forget to just keep bringing this down. Now, these equations are pretty simple because the right side is always going to be equal 0, right? But even still, I want you to make the habit of always including it in every single step of your work. That's good math. That's where, if you're careful with your math and you keep it neat and orderly, you avoid forgetting things. Because otherwise, you know what happens? You finish factoring it, you didn't keep writing it was equal to 0, and you're so happy that you got it factored, you forget that there was a question to do. Don't forget, every step of the way we're going to remember why we're doing this. We're doing this to figure out what x is when this thing equals 0. Okay, so we would say 3x squared, and that plus 4 doesn't change, but you said we're breaking that 7x into what? Yeah, plus 3x and plus 4x. Could I have switched those two numbers and it would still work? Yeah, you bet. Then what do we do with this? We're factoring by decomposition, so we kind of deal with the first half. The next line, I'm used to putting equal signs up here. Am I going to do that? No, where's the equal sign go? In line with the previous one. What's going to go on the right side of that equal sign? Yeah, I'm not doing anything over there, so I'm going to put a 0. Okay, when we factor this here, what factors out from 3x squared and 3x? 3 and x. Awesome. 3x squared with the 3 taken out and one of the x's taken out is 3x with all of it taken out is just 1. How's that feel? Cool. What can I take out of 4x and 4? Okay, so what am I going to put here? Plus 4, then x plus 1 in bracket. Oh, I see. You meant that goes in brackets. Okay. Okay. I'm sorry for being difficult. I find it fun. It brings me joy, all right? Yeah, we're factoring out the 4, so the 4 goes in front. Then we open a bracket. And then in there we say, okay, 4x with the 4 taken out is just x, and 4 with the 4 taken out is just 1. And look, those are the same, which means I can do my next line. But of course, how am I going to do my next line? Do I put the equal sign up here? No. Where does it go?
With the 0.
In line. And on the right, we haven't changed anything, so it's still equal to 0. And now, what do these have in common? X plus 1. So I write that. And then, when I take the x plus 1 out of this, I'm left with just 3x. And when I take the x plus 1 out of here, I'm left with just plus 4. So there we have it in factored form. All of that is no new math. That's just factoring the way we did in our previous lesson, right? This is all factoring by decomposition. Good job. We factored by decomposition. Have we answered the question? No. And by the way, this is where I come back to that thing. If the factoring by decomposition is just automatic and you just can do that without thinking, you don't lose your train of thought, right? When we're still new at it, the factoring is probably still going to cause you some mental stress, right? And that's totally fine. That's normal. But it's easy then to lose your train of thought. So it's always a good idea, A, to keep that equal 0 going. And now you can say, okay, now this looks just like the previous question, doesn't it? Now, it's not quite just as pretty because one of our brackets is nice and easy, right? Mm-hmm. And the other one's kind of ugly. But that's okay. Doesn't matter. What did we do in the previous one? We said, no problem. If this whole thing equals 0, what has to be true? Either the first bracket is equal to 0 or the... Can we do the same thing here? Great. So let's do that. Either the first bracket is equal to 0, which would mean what would I write here? No, not the answer. What would I write to set that up?
X plus 1 equals 0.
X plus 1 equals 0. Or, what's the other possibility? Slow. Everyone write the other possibility. And we can say either x plus 1 is going to have to equal 0, or, write it down before me. Trust yourself. What are we going to write for this one?
3x plus 4 equals 0.
3x plus 4 equals 0. Very good. Does that make sense? That's the whole point of doing this in factored form. Is if we do it in factored form, we can say either this bracket's going to be 0 or that bracket's going to be 0. Feel all right? That's not too bad, right? Now, one of these is easy to solve. Which one's easy to solve?
X plus 1 equals
Yeah,
0.
because we could just say, okay, what's the opposite of adding 1?
Subtracting 1.
Subtracting 1. I'm going to do that to the other side as well. And so x equals what?
-1.
-1. Does that feel okay?
Yeah.
All right. So that's one of our answers. This one not quite as easy, but that's okay. We can do it. We have 3x plus 4. Don't shout out. Nobody shout it out by raising a finger. That's okay. How do we solve that? How do we get the x by itself? This is grade 9 equation solving, but might be rusty, so that's okay. Yeah. Okay, and when we say move the 4 to the other side, by all means, that's how we talk. I tend to say what we're actually doing, though you're right, which is to get, what's the opposite of adding 4? Subtracting 4. Now, why did you choose dealing with the subtraction first? Doesn't BEDMAS say we multiply first? Pardon? Okay, that could be part of it. Why else? Yeah, we're not evaluating. When you're evaluating, you follow BEDMAS. But we're solving, which means we're actually working backwards. We're working from the answer kind of to the question, right? So when you solve, you never work with BEDMAS. You always work... In other words, while you're trying to get your variable by itself, you want to go in the opposite order. You always want to deal with your addition and subtraction first. Then you're multiplying. Then you deal with brackets. Then you deal with squaring and square rooting. Does that make sense? You work in the exact opposite order because you're working backwards, right? If you're evaluating, you would put the number in, then you'd multiply first, then you'd add. But we don't know the numbers, so we can't evaluate. So we have to work backwards. Okay, so subtract 4, negative 4. Our next line will be what? 3x equals negative 4. Boy, see how nice those equal signs are lined up? Boy, that looks nice, doesn't it? Looks good, right? You can admit it. Okay, how do I solve now? X, I would know x. X is equal to negative 4, but oh, actually, no, it's not. X is equal to negative 4 if we multiply x by 3. What's the opposite of multiplying x by 3?
Dividing it by 3.
Dividing it by 3. But now, because it's an equation, if I divide this side by 3, I got to divide the other side by 3. What does x equal?
X equals negative 1.33333.
Sure. Yep. Or negative
4 over 3.
4 over 3, which is my preferred answer, though if you want to put it as a decimal, go
I
nuts.
just put
That's fine.
negative 1.
Yeah, that's fine.
The negative sign, is it fine if I just write it out front of the fraction, or am I right next to the
Okay, mathematically, this is equal to this is equal to this. In general, we say that this is good form, we say that that is good form, and we tend to say that this is clumsy.
Okay, because I typically write it the last one.
Yeah.
The last one.
All three are mathematically correct. The middle one will get you bullied on the mathematical playground. The other two are fine. But to be clear, you have the right answer anyway. But this one's usually considered kind of bad manners, you know? This would be like eating your salad with the big fork and then eating your dinner with the little fork. It's fine. It's going to get the food in your face, but like grandma's not going to approve. Am I channeling my childhood again?
No.
Maybe. Anyway. My grandmother used to give us prince and princess lessons, where she would make us a nice lunch and then criticize how we ate. Well, my sister was the princess, I guess. So I think,
don't care.
realistically, looking at Amy and I'm more of the princess. But anyway,
As I get it in the mouth,
don't tell her I said so. How's that feel? And then let's answer the question. I mean, I know we have the answers, but let's still now write them down. Therefore, when, what was the original equation? 3x squared plus 7x plus 4?
Oh, I just said
When
X.
3x squared plus 7x plus 4 equals 0, x equals negative 1, or x equals negative 4 over 3.
I just wrote X equals negative.
That's fine.
1, X equals
Yeah, do you always have to write a full sentence like that? Not necessarily. Because it's the lesson, I think it's helpful for me to write it.
Oh yeah, hold on 1 second. Just gotta do something real quick.
Okay. So the key thing we want to take away from this then is, if we're going to solve a quadratic, what form do we have to put it in? Has to go in factored form, and it has to be equal to 0. In this case, that was trivial because it was already equal to 0, but the factoring was non-trivial, right? We had to factor it, but this was already equal to 0. What if it's not? No, we do algebra, guys. We do algebra. And by the time I'm done with you, you're going to be good at algebra, right? You know what we did here? Factored. Then you know what we had to do here? Just a tiny little bit of algebra. It's just a tiny little bit of algebra. And we're a little scared of it because maybe our algebra skills are rusty. That's grade 9 algebra. By the time you're done with me, you're going to be doing grade 11 algebra, and you're going to love it. All right, I promise. Stick with me. So now, let's try example 3. It's not in factored form. And it's not equal to 0.
I just wrote what if ax squared plus bx plus c doesn't equal 0.
Sure, that's fine. This is 3, right? Okay, good. Exempla gratia 3, not in factored form, not equal to 0. So let's take this one and let's say solve. Okay, can you get this right? Ready for me to get this right? You're all ready for me to get this right? Okay, good. Let's say we have x squared, so we'll make the factoring at least a little easier. X squared plus, let's say, 9x, all right, plus
76.
12 equals negative 6. Okay.
Uh-oh, not good.
Now, what are our problems here? Well, we know that we can only solve if it's equal to
0.
Yeah. See, you're so good. Yeah, of course. Yep, exactly right. You're exactly right. And we're going to note that this is, we can only solve if it's in factored form, right? So in this case, both things are giving us a problem. Which one should we deal with first?
The -6.
Why do you think that?
Because
Why not factor this first? What if we had okay, look at me. Pens down, don't write this. You'll have lots of time. What if I factored it first? What if I did, and I'm not even saying this is the right factoring, let's just say this is the right factoring. Okay? X plus 4, X plus 3. Okay? I don't know if that's the right factoring or not, but who cares? Let's say we do that. Then how would I make this equal to 0? I would have to, don't write this. Promise me you don't write this. Look at me. What would I do next to make this equal to 0? Yeah, instead of subtracting 6, I would add 6. What's that going to make this side equal?
0.
0. What will we have over here now? We will have x plus 4, x plus 3, and then it would be plus 6. Is that factored form anymore?
No.
No. This part of it is factored, but the whole point of factored form is that outside of brackets, the only operation we're doing is multiplying. Are we only multiplying here now? No. So you can't do the factoring first because then you won't, and even though you factor it, you won't end up in factored form. Does that make sense? So in this situation, first we set equal to 0, which is trivial. And then we put it into then we factor it. Does that make sense? First you set equal to 0, then you factor it. So let's take a look. I have x squared plus 9x plus 12 equals -6. How do I set this equal to 0?
You add 6.
I add 6. Good. Slow your roll a little on those answers, please, but you're exactly right. I add 6 to this side slowly. If I add 6 to this side, what else do I have to do? Slow. Sorry? Yeah, by how much? Yeah, we add 6 to both sides. Good. What's my next line? Obviously, I'll put my equal sign here because it's the next line. I mean, no. It's the next line. I put the equal sign there. Oh, I have to line it up, right? This is an equation. There's already an equal sign present. And where is it? It's right here. So I put my equal sign there. What's on the right side now? What's -6 plus 6? 0. What's on the left side now? Did the x squared change? Is it 6x squared now? No, of course not. It's just x squared. Did 9x change? No, those aren't like terms. It's still just 9x. These are like terms. What's the last term now? 18. Great. What are we going to do second? First, we set it equal to 0. What do we have to do now? We have to factor it. And this one is mercifully easy. Is there an a value?
No.
No, which means I can just know that my answer is going to be 2 brackets like this, right? And then that's equal to 0. And all I have to ask myself is 2 numbers that multiply to 18. What are they? 6 and 3, or 9 and 2, or 18 and 1. I think that's all of them, right? 4.5 times 4. But, let's not get silly here. Which one's the correct one?
6 and 3.
6 and 3. Why?
6 plus 3 equals 9.
Because it adds to the middle term. So what goes in the 2 brackets then? We know since this is x squared, what's this going to be?
X.
What's that going to be? X. And then when we multiply it out, we're going to have these 2 numbers here, and they are plus 3 and plus 6. Does it matter which order you put those in? Not one bit. All right? Have we answered the question yet? No. But we're here, so step 3 is going to be solve for x. But the nice thing here is we don't have to solve for x for the whole equation. We can solve for x in pieces, because what's got to be true here? What can I say now? Either
X equals negative.
Yeah, sorry. It's not that long. So we've done all this work, and the whole reason we do all this work is what? We want to know what number we can put in here that will make this true, right? What number can we square and then multiply by 9, add those 2 together, and then add another 12 and get -6? Would it take you a long old time to just try numbers and get that? And we already said we can't solve it, right? So we said it's much easier to solve a quadratic if instead of having it be equal to some number, it's equal to 0. So we just said, no problem. If I add 6 to this side and 6 to that side, it's the same equation, but now it's equal to
0.
0. Cool. But even then, can I spend a long old time plugging numbers in there to keep trying until they get to 0? You bet. So now, if we factor this, now there's no addition. There's just multiplication. Now, there is addition, but where is that addition? It's inside brackets, which means in terms of bed mass, there's only multiplication. Inside the brackets, we have addition. Who cares? But this is this multiplied by that. Now, here's the thing. You're looking at me. These two things multiply together to 0. What has to be true? One of two things has to be true. Either, okay, or good. How do you do that? Those are the answers, but I want to get in the habit of, and if you can skip this step, great, skip this step. But I need to conceptualize it. Because this is multiplying, the only way to multiply two numbers and have it equal 0 is if one of the numbers is 0, right? That's it, right? There's no other way. 2 times 5 is 10. 2 times anything in the world is going to be a number not 0 unless you multiply 2 by 0. It's the only way to get 0 as an answer when you're multiplying. Adding and subtracting isn't like that. You can get zeros lots of ways. If you start with 7, you can subtract 7, right? If you start with 9, you can subtract 9. But with multiplying, if you multiply by 0, the answer is 0. So if the answer has to be 0 and you're multiplying two things, then either this equals 0 or that equals 0. Does that make sense? Mm-hmm. So either x plus 3 equals
0
or
x plus 6
equals 0. And now you could do algebra, or you could just spot that the numbers are the same. But I want to do the algebra just so we get some algebra practice. What's the opposite of adding 3?
Subtracting 3.
Which I have to do to both sides, which means x equals
Negative
3. Now, you probably don't need to do algebra to do that. But if you struggle with algebra, it's not a bad idea to do it even when you don't need to. Because if you practice algebra with easy stuff, it'll help you when you get to hard stuff, like the last question, right? X plus 6 equals 0. What's the opposite of adding 6?
Subtract 6.
Great. And so what's it equal? Sure.
So under 3 subtract negative 3 is 0, right? Or am I wrong?
Yeah, exactly right.
So why does my calculator show the 6 right before?
Let me see. Probably because you're mixing up your subtraction button and your negative buttons.
Right.
So if you do 3 subtract negative 3, like that.
Yeah. Oh, no, 3 subtract
3
negative.
subtract negative 3. Sorry, 3 minus 3 is that. 3 plus negative 3 is 0. 3 subtract negative 3. When you subtract the negative, that's the same as... Yeah, and if you think that makes sense, because subtracting means get rid of, right? Yeah. And if you get rid of negative things, you become more positive. Right, does that make sense? I'm sorry. Sorry, math is stupid. Sometimes. Okay, look here. Shh. So, in this case, then, what's the answer? Therefore, x equals negative 3, or x equals negative 6. Cool. Okay. There's just one, there's a few other cases, and you'll come across them in the homework, but they're all variations on this. You always have to set it equal to 0, and it always has to be in factored form. But this, of course, begs a question, raises a question. What if you can't factor it? What if instead of this being x squared plus 9x plus 18, what if it had been 2x squared plus 9x? Yeah, oh, sorry. This is going to be example 4. You can't factor. What happens if you just can't factor it? Sometimes you can't factor it. I'm going to give you an example here where we could say, okay, what if we had 2x squared minus 12x minus 13 equals 0. Well, the AC rule would tell us we need to find two numbers that multiply to what? To what? Negative 26, which could be 26. We know that one of the numbers is going to be negative, and because this is negative, the bigger one. So it could be negative 26 and 1. Does that add to negative 12? No. Okay, it could be negative 13 and 2. Does that add to negative 12? Super close. What's it add to? Negative 11. Damn. What else? I think that's it, right? So you can't factor because there's no numbers that worked. So if you can't factor, what do you have to use? You learned this last year. Oh, you learned it last year. Oh, she's here to raise her ugly head, my friends. What do we have to use? You have to use a quadratic formula. Kelvin has like a song he sings. Does somebody want to sing it? Would you like to sing it?
No, you should sing it.
Yeah, okay, I'll get right on that. Oh, wait, no. Go. Go. You got this. We'll join in. We'll join in.
X
Equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Well, I remember
That's so
that.
hard to me that whole semester because every time, even if I wasn't writing the equation and I was like evaluating it, it was still stuck in my head the whole time.
Interesting. Everybody stand up.
Paper.
Everyone stand up.
Are we gonna like do a choir?
All together now. Kartik, get up here. Get up here. You're our conductor. Come on. I mean this. All together. All together now. All right. X, we got it. That's your note. Tenors, you can hit this note. Altos, you can hit this note. Sopranos, you can go here. Okay, we ready? We ready? Okay. La, X, go. You're good. Oh, yeah, no, lead it. You're good. We're all going to join in. We're all going to join in. I mean it. Go.
I'm not all.
C equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I feel like I'm in like a children's show from hell, but that's okay. Sit down. That was very good, though. Give yourself a round of applause. That was very nice. That was very nice. You know what the nice thing is? That was all recorded. Yeah, you're welcome. You can go back and watch that as many times as you want. You're welcome.
Yeah, join in.
So, shall we? Listen, if you can't factor, still has to be equal to 0. This is important. It still must be equal to 0. The quadratic equation assumes that the quadratic is equal to 0. If we do that, what do we call each of these numbers? We call 2, the first number with the x squared, we call that a. So we'd say a equals 2. The negative 12 is b equals negative 12. And the third one, c equals negative 13. Now listen, time to be big boys and girls. All right? I don't want any nonsense where you do this in 11 steps on your calculator. You got to learn to do a quadratic in 1 step on your calculator without making a mistake. You just do. It takes a bit of practice. So first, we write it out. We can say the answer to this will be x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Good. Okay, there we go. Boy, wasn't that pleasant. I'm good. You're welcome. Okay, listen. Just put your numbers into it. All right? Just put your numbers into it. Let's go. X equals, we put our bracket, or line here. What's negative b? Well, b is negative 12, so what's the negative of that? Positive 12. Very good. Right? Negative of negative is positive. Good. Then what do we put here? Plus or minus. And then we put the square root. And then what goes under here? What's b? Negative 12. What are we doing with it? Square it. And then we're doing what? Minus 4. And then what are we putting in here? 2. And then in here, negative 13. And that's where the square root ends. That's also where, like, the top of the fraction ends, right? And then what do we do on the bottom? All over 2 times 2. Okay. Depending on your calculator, if your calculator has a nice fraction button that lets you do math on the top of the fraction and math on the bottom, awesome. If not, look at me. These yellow calculators, we're going to have to put the whole top of this thing in a bracket, right? The whole top goes in a bracket. We'll close it. We divide, and then the whole bottom goes in a bracket. So you're going to need brackets around the whole top, divide, brackets around the whole bottom. This will take you some practice. Get going. What do I type in? 12. And then which one do you want to do first? Plus or minus? I don't care. Plus. And then what do I need? Square root sign. On your calculator, you have a square root button, right? This doesn't, so I have to do that and open a bracket. Just so we know, how many brackets are we in now? 2. So at the end, we're going to have to make sure before we get to the bottom that we've closed both of them. Does that make sense? Okay. Now what do we do in here? Well, we have to do another little bracket here, negative 12. What am I doing with it? Squaring it. You have a squared button on the calculator I have. I do this, right? What do I do next? Minus 4, and then times 2, and then times negative 13. And now I'm at the end of the square root. How do I show that? Close the bracket. I'm at the end of the top of the fraction. How do I show that? Close the bracket. Okay. It's weird, and I'm not saying you should be able to do it first try, but that's the process. Talk your way through it. Now, how do I get to the bottom of a fraction? What operation is a fraction? Division, right? So I'm going to divide. And then how do I put the whole bottom in there? Because if I just put divide by 2, then times 2, it's not going to divide by 2 times 2. It's going to divide by 2, calculate that, then it's going to multiply the answer by 2, which is not what we want to do. What do we have to do with the whole bottom of this? Put it in the brackets. Open a bracket, and this is 2 times 2, right? And then what do? Close the bracket. All right, takes a bit of practice, but we do that. We press enter, and we get an answer. And should we expect to get a nice answer? The only difference in the other one.
You subtract instead of add.
That's right, and you can do that in your yellow calculator. You can scroll back up, scroll back, and change that add sign to a subtraction sign, and it will give me the other answer. And the other answer is negative 0.93700, blah, 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 blah. No, if we're using the quadratic equation, there are times when I will ask you to leave everything in whole number form and do it as a radical on top and a fraction on the bottom. We'll get to examples like that. Not today. Though Kiki is indeed looking into your future, friends, but not today. How's that feel?
Good.
I just put my pen somewhere. The $1 million question is where? There it is. Yeah.
How did somebody come up with this? Like, did they just put it in there?
You should have learned this last year. No, not at all. They came up with it by taking ax squared. Okay, listen. You don't have to. I'm going to write the homework down, and then if you have no interest in, it's Mr. Orlando actually.
Sorry, what room would he be in?
He lives in 70, the whiteboard room. Is that 75?
75. Thank
Yeah.
you.
Sorry? Yeah, no, it's true. We built him a little bed. It's under one of the tables. We have one of those hamster water things, so he can. We put some wood chips down. He's comfortable. He's good. Yeah. That's rude. I don't. Oh, good. I'm recording this. Mr. Patch, we don't actually do that. It's not a joke. I'm not. Anyway.
I think Bro forgot.
I don't think touching watching this. He really needs to understand.
I need to let him know.
Oh, I'm such a failure. Okay. So for your homework, you're going to be on page 49, and then we're going to do 1, A, C, E, and F. All right? And then you're going to do 2, which is just using Desmos to check those. Would encourage. And then we're going to do 3, A, C, E, and F. And that'll be good homework for you. All right, you can get going on that. Kartik asked, if anyone's curious where this quadratic equation comes from, it's actually a great little proof. And if you want to come around the desk, I'll show you. But I'll let everyone else kind of get going on their homework. Yeah?
You wrote down 49 as the homework, and then you said 47, so just to confirm, it is 49?
I don't know. Go to the one near.
Everybody, the live
Here's the deal.
stream is now
It's either 47 or it's 49, one or the other. So go to those 2 pages, find the one that has questions about what we just did.
Me? Why are you yelling at me?
Because you have problem-solving skills. That is a question that doesn't need to be answered because it will be obvious when you get to the textbook, right?
Mr. Orlando.
Right? Yes, of course. Listen, did I screw up? Of course I did. Is some of this anger embarrassment that you pointed out that I screwed up? Probably. But am I also annoyed that you're displaying a lack of problem-solving skills? Yes. You can figure it out. You're smart.
Mr. Orlando.
Would
Mr.
both of
Orlando.
them have the same amount of questions?
then why do I care which one you do? If both of those pages happen to have questions 1, 2, and 3, and they're both about factoring and solving quadratics, then I don't care which ones you do. Go nuts, have fun.
I'm not gonna. I'm actually gonna cry myself to sleep.
No, you're not.
So you always mentioned, like you should have done this last year, but I ended up failing grade 10 math.
Oh no.
I'm confused how I'm even in this class.
That's a good question. But listen, if you didn't learn it last, because the other thing I say after that every time is, but if you didn't, we got it.
Yeah.
So listen, are you gonna have a harder go at this than somebody who didn't? Yeah, of course, right? Yeah, but that's okay. You can do it. You're smart. You got the skills. As long as you stick with it, we'll help you. So just every time I say that, you know who I'm not talking to?
Yeah.
I'm not talking to you,
Yeah.
and that's okay. Like it doesn't matter. You're gonna get there in the end. Is that fair?
Yeah.
Okay.
I'm just confused how
Hey, wait. Are you still streaming? Are you still on stream?